Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we're going to go more in depth about why we developed CopperSpice.
We believe talking about the origins of CopperSpice and why we started this project will help the community understand our project better. There's been a lot of speculation about our motives, and we want this video to clarify our intentions.
The decision to start CopperSpice is not one we made lightly. In fact, we spent several months talking about how we could contribute to Qt and if that would work for us. Ultimately, we realized Qt was going in a different direction. And the first step of CopperSpice was deciding what we should retain and what parts we needed to change.
With that in mind, we'd like to tell you how everything started.
Why CopperSpice? Back in the 90s, I was working as a developer, writing GUI applications. The language I was using was called Visual Objects. This is a language that was very similar to Smalltalk. It wasn't widely used, and development on the language started to dwindle. The other issue with Visual Objects is it's only for the Windows environment. I wanted to move away from Visual Objects, and the first thing I thought about was moving to Java. There were problems using Java.
We discovered all sorts of performance issues and a lot of missing features, but most importantly, it just didn't feel like a comfortable language to work in.
After we tossed out developing in Java, I really decided that the best language we needed to use was C++. The only problem with C++ is there is no GUI interface. This is not part of the language. So we needed to find a GUI library. Ansel and I spent some time and we looked around at what GUI libraries were available. And the best one we found was Qt. So I started developing my GUI applications using C++ and Qt. This was around 2009. As I started really getting into using Qt, I found out the samples that they had didn't even build. I started discovering that there were issues related to stale generated files. I wasn't sure what the problem really was. Was it my not understanding C++ or Qt, or were there fundamental issues in Qt? So Ansel and I teamed up and we started to look at could Qt be improved to solve the problems we were running into. To do this, we had to look at what were the limitations of Qt.
And we started finding many of them. For instance, there were problems with using complex data types as properties or as the arguments to signals and slots. You'll note that in QMAP QString bool, there's a comma, and no data type with a comma can be used in the property system. There's also issues with type defs being used consistently between the signal and the slot declaration. We ran into issues with templated classes because templated classes cannot inherit from QObject since the meta-object system didn't understand templates. And as a result, we could not create a templated class that contained a slot. There are issues with the container library, in particular QList, and we encountered difficulty with QString since it uses UCS2, which is a bit challenging to use on occasion.
One of the other problems we found was related to memory management. QPushButton is a widget, and it's part of setting up a screen in the GUI environment. It must be constructed using new. The QPushButton is then attached to a widget. Ansel found this extremely odd that he saw the new that was in my code and he questioned where was the delete.
The answer is that when the push button is added to its parent widget, it becomes a child. And when the parent widget is destroyed, it automatically deletes all of its children. This is an understandable memory management system. However, it can be very difficult to read code and determine whether it's correct. Because if a particular object has no parent, you must call delete. And if an object has a parent, you must not call delete. And it's very difficult to get this right consistently in a large and complex code base.
So we sat there and we looked at Qt, and we said, now what? Do we find a different library? Do we hope the maintainers improve the library? Do we live with it? Ultimately, what we decided is that we should actually contribute to Qt, because this is what you do with an open source project. You identify the problems, you develop solutions, and you contribute to a project.
So the question was, can we contribute to Qt? And the first issue that we encountered is the fact that the Qt company develops and releases both a closed and an open source version of their product. And in order to contribute to the Qt library, you must sign a contributor license agreement. And this CLA allows the Qt company to take any contributions that are provided and put them in a closed source product rather than the open source version of Qt. So that was one issue that we were slightly uncomfortable with. But the real question was, would they accept our changes? Because we had some ideas about things we wanted to do with the core library that were simply not compatible with the direction of the Qt project.
One of the other problems we knew that existed with Qt was the meta-object compiler. Mach is a code generator. The build system runs Mach on your H files to produce CPP files. These CPP files are compiled and linked into your user application. As I mentioned earlier, I noticed that some of my files when I was building were stale and causing build problems. This is where it happened.
So one of the chief problems with Mach is the fact that most build systems have only limited support for it, or no support at all. And it is quite common to have the Mach-generated files get out of sync with your source code, which produces some extremely difficult to diagnose errors. There are also a number of issues having to do with Mach itself, primarily having to do with the parts of C++ which it does or does not understand. As I mentioned earlier, it has issues with templates and types that contain a comma. The generated code primarily consists of large string tables and methods which implement the signal system. And every parameter that's passed to the signal method is cast to a void star before being sent through the rest of the signal delivery mechanism.
So the real question is, what did Mach solve? C++ does not natively implement or support reflection, and reflection is required for the signal slot delivery system, for metadata, plugins, and several other parts of Qt. There are ISO study groups that are looking at how to add reflection natively to C++. They thought they would have it for C++ 17. That obviously didn't happen. And it's very unlikely they're going to make it in C++ 20. I do expect at some point we'll see reflection natively in the language, but for now it's not there. So the question is, can Mach be replaced by using only modern C++? And can this be done today without having to wait for anything to be added to the language? And the answer is yes. So let's take a step back and look at how the Mach utility is actually generated. It's written in Qt, and Mach must be built before building the Qt core library.
This poses a Bootstrap problem because Qt core must be built before building Mach. So the solution to this was to build Qt core in a special Bootstrap mode, turning off a great deal of the code with if-defs so that Mach could then be built to produce the real Qt core. This same issue arises with QMake, because QMake also is written in Qt and requires the Bootstrap version of Qt core. And Qt is built using QMake. So this Bootstrap process is quite complex and error-prone. And one of the first things we were able to do when we removed Mach is remove a tremendous amount of if-def dead code for various platforms to support the Bootstrap process.
So CopperSpice not only doesn't require the Mach utility, it doesn't require the Bootstrap library, and it no longer uses the QMake build system. This is where we improved the core library tremendously. We thought it would be interesting to explain a bit of the history of the product. Nokia bought Qt from Trolltech in 2008. There was a major reorganization in February of 2011. Nokia then decided to sell the licensing to Digia. Digia ended up acquiring Qt from Nokia in September of 2012.
For more information about this history, you can find a detailed timeline in the CS overview documentation on the CopperSpice website.
So in May 2012, we forked Qt 4.8 and started CopperSpice. The first thing we needed to do was set up a build system. We did choose to use the GNU AutoTools build system because this is what we were familiar with. It's very important to let everyone know we fully support CMake, and this was added in July of 2015 by a contributor. The QMake build system is completely obsolete.
We have also completely removed Mach. That was one of the first things we did. Mach is not used in any part of CopperSpice. It's not used when building your CopperSpice applications. And the entire reflection and metadata system is completely native in C++ code in CopperSpice.
There's quite a few libraries that actually make up CopperSpice. CS Core and CS GUI are the main libraries worth noting. The core library is where you're going to find all the fundamental classes like the string classes, the container classes. And CS Core is used by all of the other CopperSpice libraries.
We started the CopperSpice project in 2012, and we chose C++ 11 as the minimum standard. But the truth is, we had no choice but to use C++ 11, since we ended up needing type traits and enable if and nearly every other feature of C++ 11 along the way to replacing Mach. We needed these features of C++ 11 not just to remove Mach, but also to implement an improved property system and increase performance in the signal slot delivery mechanism.
Another area of concern were the containers. Many of them have exception safety problems. The containers in Qt are hand-rolled, and they're missing features which most C++ developers would require.
QList in particular has many implementation issues. It can have severe performance degradation under certain conditions, and its use is not recommended. However, if you're writing an application in Qt, it's almost impossible to avoid QList since it's used in the API for many methods.
The containers in CopperSpice have been refactored to leverage the standard library. In the process of doing this, we were able to change some of the implementation. For instance, QMultimap and QMultihash no longer inherit from QMap and QHash. They actually leverage STD multimap and STD unordered map. QVector and QList are now implemented correctly, with QList actually leveraging stddeck.
As part of this refactoring, we gained access to move and copy constructors as well as reverse iterators for every container. We were also able to refactor and simplify both the Java and STL style iterators that were provided in the CopperSpice API.
There's two other libraries we've been working on. One is the CS Signal library, and the other is CS String library. These are both BSD libraries, and in fact, they're standalone libraries. We have integrated both of these libraries into CopperSpice, but they can be used independently and without CopperSpice if this is functionality you need in a C++ application you're working on. The CS Signal library adds support for cross-thread signal delivery and improves the signal slot delivery system. The CS String library adds UTF-8 support and maintains the UTF-16 support. By removing Mach and changing the build system and altering how containers are implemented, we've gained functionality in CopperSpice. CopperSpice allows a templated class to inherit from QObject. Compound data types are now supported in the signal slot delivery system. You can pick any build system you want to use. We've refactored atomics. We've enhanced the property system. And we have brand new API documentation that fully documents everything in CopperSpice. It's very important to us to establish that CopperSpice is not Qt 4 and it's not Qt 5. It is a different project.
We look at this the way you would compare two hotels. Every hotel provides a similar service, but each one is unique. They all have different amenities. One may have a fitness center, one may have a pool. The breakfast may be different at different locations. Some may have free Wi-Fi. Not everyone has the same requirements, and that's why there are different types of hotels. And the fact that there are these different hotels encourages innovation in the industry.
CopperSpice has gone in a different direction, and we see it as a set of libraries that can be used to enhance C++ functionality rather than just a framework that uses C++ as its internal language.
Here's a list of the platforms that we currently test CopperSpice on. If there's one missing, let us know, or feel free to start testing and then submit a pull request. This is a list of the compilers we support and the versions of them that we're currently using in continuous integration.
PepperMill is a parser I wrote so that we could automate the process of converting the headers for Qt to the CopperSpice syntax. It's a utility that I only needed to run one time. We've also released the PepperMill utility for anyone who's migrating from Qt to CopperSpice. You don't need to use PepperMill. You can change the syntax in your header files by hand, but why bother? Run it once, convert your syntax, and then you can go ahead and use CopperSpice.
For more information, visit our website, www.copperspice.com. You can find all of our source, binaries, and documentation on our download site, and you can find all of our source code in our repository on GitHub.
Thanks for watching our video, and we hope you found the content of value. If you have any questions, feel free to email us or leave a message on our CopperSpice forum. We really do want to hear from you.
Please make sure you subscribe to our YouTube channel and come back in 2 weeks for our next video.